Welcome back, everyone. Today, we're decoding exactly how marks are awarded for question 5 from the Pearson Edexcel GCSE Maths Higher Paper 3H, specifically the November 2023 edition. Let's just jump right into the exact wording of the official mark scheme. Okay, let's dive right into this. What exactly is the path to full marks for question 5? Well, we're going to look at the required mathematical processes, the accepted alternative methods, and, of course, the exact final values you need to get those points. To get started, we really need to understand what a P1 mark is. In the Edexcel grading system, P simply stands for process. So this is a process mark awarded for a correct process as part of a problem-solving question. Before an examiner even glances at your final answer, they're actively scanning your page to see if you've initiated a valid mathematical process. So the crucial point is, how do you actually trigger that very first process mark? Well, the November 2023 mark scheme explicitly requires the start of a process to find common multiples of 30 and 24. Basically, if you don't show an attempt to find these common multiples, your path to full marks is just blocked immediately. No way around it. Luckily, the mark scheme outlines 3 specific ways to demonstrate this start. Method 1 is the listing strategy. It's honestly the most straightforward, kind of brute force approach you can take in the exam. Literally just start listing out the multiples of both numbers. But there are strict rules about exactly how much is enough. To get the mark here, a candidate has to write down at least 3 multiples of 30 and at least 3 multiples of 24. Both of these conditions absolutely must be met. The examiner is literally going to count your numbers: 30, 60, 90, and 24, 48, 72. Showing this clear progress toward the lowest common multiple of 120, that's what locks in that P1 mark. Now let's move to alternative starting methods and see how this builds. Because hey, math always offers a bit of flexibility. Maybe you get nervous under pressure and accidentally skip a multiple while listing. Or maybe you just prefer a more visual way to break down numbers. The mark scheme fully anticipates this, offering alternative starting methods that are just as valid. First up, you can draw factor trees for both 30 and 24. This clearly shows you're breaking the numbers down into their prime factors to find that lowest common multiple. Alternatively, you could draw a correct Venn diagram representing those prime factors. Both of these visual structures prove to the examiner without a doubt that you've got a completely valid mathematical strategy. But notice a crucial warning attached to the factor tree method. The scheme specifically says, with no more than 1 error in total. This really highlights a super common pitfall. The examiner will forgive one single little arithmetic slip-up, but if you make 2 small calculation errors while branching out those factors, you lose the entire P1 mark. So you really must maintain accuracy if you're going to choose this route. All right, assuming you've flawlessly executed your process and figured out that the lowest common multiple is 120, we shift gears to the A1 mark. This is an accuracy mark, and it is strictly awarded after a correct method or process. Basically, if a student just scribbles final numbers down with 0 working out, they risk losing the marks entirely. The A1 mark is essentially your reward for carrying that correct process all the way to the finish line. The final answer. So, having found our lowest common multiple of 120, what are the exact magic numbers that actually trigger the final accuracy marks for question 5? Let's reveal them. The first number is 4. Since our lowest common multiple is 120, we just divide that by 30 to get 4. The mark scheme requires an exact answer of 4 packs to lock in this first accuracy mark. And the second number is 5. We divide our common multiple of 120 by 24. And that gives us 5 boxes. Stating 4 packs and 5 boxes completes the primary answer key for the whole question. Now, this next part brilliantly illustrates a pretty fascinating aspect of the grading process. The mark scheme actually includes alternative instructions, or 6.25 and 6, meaning if calculations led to these specific values based on a slightly different but still valid interpretation, they're actually rewarded. Furthermore, there's a very specific leniency here to condone incorrect units given. So if you did all the math perfectly to get 4 and 5, but accidentally wrote 5 packs and 4 boxes, the examiner completely condones it. You won't lose math marks just for a brief lapse in vocabulary, which is great to know. So we've walked through the exact requirements, right, from the first process point all the way to the final accuracy marks. So I have to ask, which of the 3 acceptable P1 methods would you feel most confident using under exam pressure? Listing, factor trees, or Venn diagrams? Remember, knowing exactly how the examiner thinks is absolutely your greatest advantage here. Keep practicing, stay focused, and I'll catch you in the next explainer.